Hello, everybody. Today, I want to go further on our journey through electrolysis, and we are going to look at what happens at the electrodes. So, at the end of today's class, you should be able to understand the difference, to differentiate between the electrolysis of molten electrolyte and aqueous electrolyte. You should be able to predict the products of electrolysis based on the state of the electrolyte, either molten or aqueous. You should be able to determine the substances liberated at electrodes based on the position of ions in the electrochemical series, also known as reactivity series, and evaluate the effect of electrolyte concentration and the nature of electrodes on electrolysis products. And finally, to apply all the learned principles to predict electrolysis products in various scenarios. So let's get started. So, we want to start by looking at the differences between electrolysis of molten substance and an aqueous electrolyte. So when we say molten electrolyte, remember, molten, it means a substance is melted. So we can have the salt that we put in our food. You remember the salt is crystalline. And then if the salt is heated strongly in the laboratory, the salt will become liquid. And then so this is our solid salt, and this is our liquid salt. This liquid salt is formed when the solid salt is melted. So this is going to be our molten salt. The liquid one is our molten salt. And also, remember when you put water in your refrigerator, it becomes ice, and then you bring the ice out, and then the ice will melt and become liquid water. So that is different between, that is what we mean by a molten substance. What about a solution? A solution means you have a mixture of a solute, that is a mixture of solid, but that solid is dissolved in a solvent, and that solvent is water. So remember, this substance will say solvent plus solute give us what we call a solution. Now, when we say aqueous solution, it means our solvent here is water. So when your solvent is water, that solution is an aqueous solution. Okay. Now, electrolysis, all our electrolyte can be a molten substance. It can be a molten substance. It can be an aqueous solution. So let's look at a molten electrolyte. So whenever an ionic compound is molten, that is when you melt an ionic compound, the only mobile ions present are those from the compound itself. I have my sodium chloride, NaCl, which is solid, and then I melt sodium chloride to become molten sodium chloride. When it becomes molten sodium chloride, we are going to have it as Na plus and Cl minus, which is not aqueous this time around, remember, because it is not dissolved in water, so it is not aqueous. So instead of aqueous, it will be what? It will be liquid. So this is molten sodium chloride, and it is solid sodium chloride. Now, the molten sodium chloride has ions. This one, solid, does not have an ion. The molten has two ions, and the first one is our sodium ion, and the second one is chloride ion. So whenever you melt an ionic solid, you will have two types of ions. That is, the ions that come from that solid. For example, if you melt magnesium sulfate, MgSO4 as an example, you're going to have Mg 2 plus and SO4 2 minus as your ions in the solution. If you melt sodium, so this is sodium chloride. If you melt like copper oxide, CuSO4, CuO, copper 2 oxide, you're going to have, if this copper 2 oxide solid, if you melt it, you will have copper ions, Cu 2 plus and O2 minus. You will have 2 ions only. So the positive ion, that is the cation, and the anion from your salt that is melted. Now, and those are the ions that will be present in your electrolyte. Only 2 types of ion. So let's have a look at this diagram here as an example. So let's say this is electrolysis of molten sodium chloride, NaCl liquid. Now, this is going to be our anode, and this will be our cathode. Remember, anode and then cathode. And then in the electrolyte, we are going to have molten sodium chloride, and you have it in front of in form of sodium ion and then chloride ion. So you have many sodium ions and many chloride ions in the solution. Only 2 types of ions. Now, whenever you pass the electricity, you supply electricity from your DC source here, for example, like battery. So this is going to be the positive side of the battery, and this is going to be the negative side of the battery. Remember, the negative side, I said, has more electrons than the positive side. So it means electron will come out of the battery from the negative side, which is and then it goes to the cathode. Cathode is negatively charged. So we have 2 types of ions in the solution, Na plus and then Cl minus. Now, remember, this is negatively charged. And remember, unlike charges will attract, we mentioned that in the past. So it means the cation will move to the cathode. And that is why we call it cation. Cation means ion of cathode. Cat, ion, the ion of cathode. So the positive ions are ions of cathode because cathode is negatively charged. So the Na plus will be migrated towards the cathode in order to catch the electron that is coming towards it. So something like this. Z. So you have this. So this one will take the electron that is coming. So when it takes the electron, this is very easy. We can write that in form of an equation. That is, our cation, which is Na plus, takes electron from the cathode, and then it becomes what? This is positive charge, this is negative charge. When they come together, they will neutralize each other. So you're going to have Na without a charge. So this is going to be the product at the cathode, sodium solid. We have sodium ion in the solution, which is liquid, and then it gains electron at the cathode and then becomes sodium solid. So the same thing, the opposite will happen at the anode. The guy that has a negative charge will move to the anode and release the charge on it. So we have Cl minus goes to the cathode and release the electron. That is, release the charge, release negative. It releases that negative charge, and then when there's no charge, when it releases this charge, it means there will be no charge on the chloride atom only. So you're going to have chlorine atom here instead of chloride ion because that electron has been released at the anode. So the arrow will go up at the anode like this. So eventually you have chlorine gas this is chlorine atom. It's not a gas yet. It becomes gas if it is a Cl2 chlorine molecule. So this is an atom. And then remember, chlorine, I told you that something like element like chlorine, like bromine, like iodine, like fluorine, like nitrogen, like oxygen and hydrogen. There should be 7 of them. Yeah, all these 7 elements, they exist naturally as what? As diatomic elements, diatomic molecule. So naturally, this is going to be chlorine gas Cl2, Br2 naturally, I2, F2, N2O2, and then H2. When you want to represent them in an equation, you want to write them only. They are not in compound. You want to show them standing alone in an equation. You have to put 2 in front of the symbol to become a molecule. So if you put 2, if there is Cl2, it means, I will remove this 2 first. What we have here is like 1 chlorine ion releases 1 electron to give us 1 chlorine atom. If it becomes 2 chloride ions, see where I put 2 for the chloride, I put it at the back, 2 chloride ion. It means there will be 2 electron released. So it's going to be 2 electron released. So there are going to be 2 here. And then it becomes a chlorine molecule, Cl2. Please look at where I put the 2 for the chlorine molecule. Molecule will have a subscript 2, but the ion will have the 2 in form of mole, like you have 2 moles of chloride ion. So that is what happened at the, so we can put G here now as gas. And this is what happened at the what? At the anode. And that is what happened at the cathode. And remember, this is gain of electron. So this is oxidation at the anode, at the cathode. And then at the anode, it is loss, sorry, this is reduction at the cathode because it's gain of electron. At the anode, it is loss of electron, which is oxidation. That is the electrolysis of a molten substance. Any other, the question they may ask you regarding this is, what is going to be the product? It is very, very easy. The product at each electrode of electrolysis of molten salt is going to be the element that comes together to give you that molten salt. For example, if I have copper 2, if I have magnesium chloride, Mg, Cl2 as my salt, and then we melt it to become MgCl2 liquid, that is molten MgCl2, and then we use it as our electrolyte, and then they now ask you what's going to be the product at each electrode. You know that magnesium is positively charged, Mg2+. You are going to have magnesium atom, not magnesium ion. You have magnesium atom at the negative electrode, which is the cathode, and you have chlorine gas at the anode, which is the positive electrode. Why? Because you have only magnesium and chlorine as the ion in the solution. So you don't have any other ion with them. So when you are dealing with electrolysis of a molten substance, you will get 2 substances, one product at the anode, the other one at the cathode, and then those products are the atoms that come together to give you the salt